Welcome to AP Environmental Science. In this video, we are going to talk briefly about the layers of the Earth's atmosphere. So the Earth's atmosphere is primarily composed of nitrogen gas. In fact, nitrogen makes up about 78% of the Earth's atmosphere. The rest of it, about 20%, would be actually made up of the oxygen that we need to breathe to do cellular respiration within our bodies to stay alive. So when you say that you're breathing air, in fact, you are breathing mostly just nitrogen gas. The remaining 2% is made up of trace gases, and this is where we have our heat-trapping gases or our greenhouse gases. This includes water vapor, carbon dioxide, methane, and this also includes ozone. Now, if we compare the atmosphere on Earth to the atmosphere on Mars, because people have this fascination with trying to find life on Mars, it's important to note that the atmosphere on Mars is actually made up primarily of carbon dioxide, and there is very little nitrogen and oxygen available in that atmosphere. Now, the layers of the atmosphere are actually determined or delineated based off of changes in the temperature. Now, anytime that we go from one layer to the next, we call that transition a pause. And that's just the area where the temperature changes from increasing to decreasing or vice versa. We're going to go through each of these layers from closest to the Earth all the way out to outer space, and you are going to need to know these layers in order along with the general trend of what's happening there. So the layer closest to the Earth is called the troposphere. Now, the term tropos actually means change, and this gets its name from the changing weather patterns and the constant mixing that takes place close to the Earth's surface. So the main characteristic that you need to know about the troposphere is that this is the location of the weather on Earth. Now, most of the nitrogen, oxygen, and water vapor are found within the troposphere. The next layer up is the stratosphere, and strat actually means layer. So the stratosphere actually has its own set of layers, which is pretty fascinating. In fact, the stratosphere is the location of the ozone layer, and you need to know that. So the ozone layer is this pale blue gas that actually absorbs and reflects a lot of the UVB and UVC radiation from the sun. This is what acts as that blanket that helps to protect the Earth from having major temperature swings due to changes in that daily amount of sunlight. Now, it's important to note that there is no mixing in this layer. That is what allows these layers to develop. And this is cold at the bottom and warm at the top. It's actually the opposite of the previous layer. The next layer is the mesosphere, and the word meso means middle. Now, this is the highest layer in the atmosphere where the atmosphere's gases are constantly mixed. So that means they are not actually arranged in layers. And the fun fact about the mesosphere is that this is the location of shooting stars or meteors because this is the layer of the atmosphere where it's now dense enough to create enough friction to cause those meteors or shooting stars to actually burn up. Above the mesosphere is the thermosphere, and thermo means heat. This is the location of the northern lights or the aurora borealis. Now, here's the thing. In the thermosphere and beyond, it is actually quite hot. However, if you were out and exposed there, it would feel very cold, even though it's really hot. And that's because the gas molecules are spread so far apart that they're not able to actually transfer their heat to you. This also means that there are not enough molecules for sound waves to travel. So this is an incredibly quiet and it feels very cold out in the thermosphere. Beyond the thermosphere, we have our exosphere, and this is outer space. This is the outermost layer of the atmosphere. And the prefix exo means outside. Now, the exosphere is primarily made of hydrogen and helium gas, and again, the exosphere would feel very, very cold because the molecules are spread so far out that they couldn't transfer their heat to you. So in summary, and I highly recommend that you sketch this graph into your notes to see the general trends between each of the layers of the atmosphere. You need to know the overall composition of the Earth's atmosphere. You need to know it's 78% nitrogen, about 20% oxygen, and you need to know some of those trace gases. You also need to know the general characteristics of each layer and their order. So I like this graph because it shows you that starting at the ground level, the troposphere starts relatively warm and gets colder as you get further away from the surface of the Earth. Then in the stratosphere, we start to have layers, and as you get past the ozone layer, it starts to warm up a little bit. You get to the mesosphere and things start to cool down again. Now notice we never really get to comfortably warm temperatures again once we get out of the troposphere until you get into the thermosphere. However, in the thermosphere, those particles are spread so far apart that it actually feels incredibly cold there. Now, please send me your questions. I'll get back to you as soon as I can, and I hope that as you watch this video, you were able to learn something.